If the local electrical inspector is not helpful, contact the building department. They have the authority to enforce building codes, including electrical codes. Explain the situation clearly and provide evidence of the code violations. Having a copy of the National Electrical Code Handbook will be invaluable. If the building department does not take action, the next step is to contact the State Electrical Board. These boards regulate the licensing of electricians and have the power to investigate complaints. Again, provide detailed information about the code violations and the electrician's unprofessional behavior. You can also file a complaint with the National Fire Protection Association, which oversees the National Electrical Code. The NFPD can investigate code violations and offer guidance to local enforcement agencies. You can submit a complaint online at their website. To further support your case, consider hiring an independent electrician to conduct a thorough inspection of the electrical work. Request a detailed report outlining any and all code violations discovered. This report can serve as concrete evidence to bolster your complaint with the building department or State Electrical Board. As a final recourse, you might consider legal action against the electrician. However, understand that this can be a complex and costly undertaking. Consult with a legal professional before pursuing this option. Remember to meticulously document all communications you have with the electrician, inspectors, and any other authorities involved. Maintain a record of dates, times, and the content of your conversations. Take photographs or videos of the code violations to visually document the issues. Throughout this process, remain calm and professional in all your interactions. Present your concerns clearly and respectfully. Finally, stay persistent in your efforts. Do not give up until the situation is resolved and you are confident that the electrical work meets all code requirements. Remember, your safety and the safety of your family are the top priority. Code violations can create dangerous electrical hazards and undermine the structural integrity of your home. It is crucial to address these problems promptly and ensure that all electrical work is brought up to code. Here are some additional things to consider during this process. Firstly, ensure that any new electrician you hire is properly licensed and insured. Secondly, obtain multiple quotes for the necessary repairs or corrections to the electrical work. Thirdly, verify that the new electrician pulls the necessary permits for the work being performed. Fourthly, ask the new electrician to explain the code violations in detail so that you fully understand the issues. Fifthly, keep a copy of all permits, inspection reports, and invoices for your records. Sixthly, if you are uncomfortable with any aspect of the work being performed, do not hesitate to ask questions or raise concerns. Seventhly, be prepared to invest the time and effort needed to resolve these issues. Resolving electrical code violations can take time and require persistence. Eighthly, consider joining online forums or groups related to electrical safety and code compliance to gain insights and support from others. Ninthly, familiarize yourself with the specific electrical codes that apply in your jurisdiction. Your local building department can provide you with this information. Tenthly, if you encounter resistance from local authorities, consider contacting a state representative or senator for assistance. 11thly, do not attempt to perform any electrical work yourself unless you are properly qualified and licensed. Electrical work can be dangerous, and improper installations can create serious hazard. 12thly, if you suspect that the electrician has engaged in fraudulent or unethical behavior, report them to the Better Business Bureau or other consumer protection agencies. 13thly, be aware of your rights as a homeowner, and do not be intimidated by contractors or inspectors. 14thly, if you are selling your home in the future, be sure to disclose any electrical code violations to potential buyers. Failure to do so could result in legal issues down the road. 15thly, consider having a whole house electrical inspection performed periodically to identify any potential problems before they become serious. 16thly, install arc fault circuit interrupters, often called FSIs, and ground fault circuit interrupters, often called GFCIs, to protect against electrical fires and shocks. 17thly, make sure that all electrical outlets and switches are properly grounded. 18thly, avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. 19thly, use extension cords sparingly and never run them under rugs or furniture. 20thly, replace any damaged or frayed electrical cords immediately. 21stly, keep electrical appliances away from water to prevent electric shock. 22ndly, teach children about electrical safety and the dangers of electricity. 23rdly, in the kitchen, it is essential to have the appropriate number of 20 amp small appliance branch circuits as per the National Electrical Code, or NEC. Typically, a minimum of 2 such circuits are required to handle the loads of various kitchen appliances. Receptacles that serve countertop areas in the kitchen must be supplied by these small appliance branch circuits, ensuring adequate power for countertop appliances. Overloading these circuits with too many appliances or permanently connected loads like lighting or garbage disposals violates the NEC and poses a safety risk. The NEC provides detailed guidelines on the number of outlets required along countertops, specifying that no point along the countertop should be more than 24 inches from a receptacle outlet. This ensures convenient access to power for appliances. Furthermore, all 125-volt, 15 and 20 amp receptacles serving kitchen countertops must be protected by a ground fault circuit interrupter, or GFCI. This is crucial for preventing electrical shocks in a wet environment like a kitchen. Recessed lighting, under-cabinet lighting, toe-kick lighting, and garbage disposals should not be connected to the small appliance branch circuits. These items should be on their own dedicated circuits to avoid overloading the small appliance circuits. 24thly, with regards to switch boxes, NEC Article 314 covers the requirements for outlet, device, pole, and junction boxes, conduit bodies, fittings, and hand toll enclosures. Overstuffing a 3-gang switch box to the point of breaking a switch and causing circuit breakers to trip is a clear violation. The NEC specifies fill requirements for boxes based on the size and number of conductors, devices, and fittings contained within the box. These requirements are designed to ensure that there is adequate space for heat dissipation and to prevent damage to conductors and devices. When calculating box fill, each conductor that originates outside the box and terminates or is spliced within the box is counted. Each conductor that passes through the box without being spliced or terminated is also counted, with some exceptions for equipment grounding conductors and short lengths of conductor used for equipment grounding. Device yokes, such as switches and receptacles, also contribute to the box fill calculation. The NEC provides specific volume allowances for each device based on the wire size. If the box is too small to accommodate all of the conductors, devices, and fittings, the box must be replaced with a larger one. The NEC also prohibits damaging conductors or devices when installing them in a box. Stuffing too many wires into a box can damage the insulation on the conductors, which can lead to short circuits and electrical fires. 25thly, the NEC requires arc fault circuit interrupter protection, or AFSI, in bedrooms to protect against electrical fires. AFSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when insulation on wires becomes damaged or when there is a loose connection. When an arc fault is detected, the AFSI will trip the circuit breaker, cutting off the flow of electricity and preventing a fire. The NEC requires AFSI protection in all branch circuits that supply 120-volt, single-phase, 15 amp and 20 amp outlets installed in bedrooms, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. Some jurisdictions may have additional requirements for AFSI protection. It is important to check with your local building department to determine the specific requirements in your area. If the electrician stated that the inspector does not recognize AFSIs, their statement should be scrutinized with local code enforcement, as AFSIs are a critical safety component. 26thly, NEC 210.52 addresses the placement of receptacles in dwelling units. The code mandates that no point along a kitchen countertop should be more than 24 inches from a receptacle outlet, ensuring that appliances can be easily plugged in without the use of extension cords. Cutting a stud in a load-bearing wall to install an electrical box is a structural violation and a dangerous practice. Load-bearing walls are designed to support the weight of the structure above, and cutting a stud can weaken the wall and potentially cause it to collapse. If an electrical box needs to be installed in a load-bearing wall, it is important to do so in a way that does not compromise the structural integrity of the wall. This may involve reinforcing the wall or relocating the box. 27thly, the use of underground service entrance cable, often called use, for subfeed from the main panel is a concern. Use cable is designed for direct burial in the earth and is not intended for use inside a building unless it is protected by conduit. The NEC specifies the types of wiring methods that are permitted for different applications. In this case, the use cable should be replaced with a wiring method that is approved for indoor use, such as non-metallic sheathed cable, often called NM cable, or electrical metallic tubing, often called EMT. When running cable through concrete walls, it is important to protect the cable from damage. This can be done by using conduit or a sleeve. The NEC requires that cables be protected from physical damage, and running them unprotected through concrete walls is a violation. Furthermore, cables should not be allowed to lay directly on the ground in a crawl space. The NEC requires that cables be supported and secured in a neat and workmanlike manner. Laying cables directly on the ground can expose them to moisture, rodents, and other hazards. 28thly, the service drop or service entrance conductors must have adequate clearance from the roof and other structures. The NEC specifies the minimum clearances required for service conductors. In this case, the weatherhead should be at least 36 inches above the roof, and the drip loop should not be touching the roof. The drip loop is designed to prevent water from entering the service equipment, and if it is touching the roof, it will not function properly.